Hi, welcome back to building a Trello clone using the need stack. This series of videos is introduction or introduction to what you can do with TypeScript and using Angular on the front end and the Nest.js on the back end. In the last episode, we scaffold the Nest the back end using the Nest CLI, and we did a few configurations to the basic package, to the basic files that were generated. Like for example, we add the ability to specify what port to listen to, etc. Okay. In this episode, what we will do is two things. We will begin to build out our data model, which will eventually support the Angular front end that we have built in season 1. And what we'll also do is that we will create a connection pool for the database. The database we'll be using is MySQL, and this is the data model that we will be using. It's a very simple data model. It's got 3 tables. One is a user, so we have a user ID, an email, and a password. And then it has a one-to-many relationship. So one user can have many kbots. So every bot will have a bot ID, user ID, title, comments created on, etc. And then one bot will have many cards, right? The card ID, etc. If you go back to the season 1, you'll find that this is reflected in what we have created. Okay, so let's start by building out this data model. I've already installed MySQL, so I won't be repeating that, and there are numerous tutorials again to install MySQL, so I won't be adding to that. So let's start by, as usual, let's create a new branch. We'll call this part 19, and then we'll just have a look. Okay, right. We'll go to our, okay, I will now create a directory. I'll put all my SQL files into this directory called database. Okay, and also let me start the MySQL client. I'm using my CLI. I'll log into root. Okay. Before we start, I will create a user. I'll create a user called this is the MySQL user. Eventually we'll use this user to log in. I will call it create user. I will call it Barney. And all this is the wildcard, right? So we will Barney can come in from any server. Identified by, this is the password, and just to keep things simple, I'll call Barney. Please never use this as a password. We have created that, and what we'll do is this: we will flush the privileges first. Okay, and let's have a look at the user. Select user from MySQL, and notice that Barney is created here. Okay, so let's go and create the database, and then we will grant Barney access to our database. We'll start off by creating the schema. We'll write a file called schema. So recall, this is the model that we are going to create. I will say drop database if exists. I'll call my database need stack. Create database need stack. Okay, and then I'll use the database. Okay, so that's the easy part. We will now create the first table, user. Create table user. Okay, and user has 3 fields: user ID, which is the primary key. So we will say not now. The user ID will say varchar of maybe 16 characters, and then the next one is email, right? Email, we'll say varchar maybe 64. finally we have password. We will say var char 128 now, and then we will say the user ID is our primary key. User ID, and then I'm also going to create another index on email. Okay, so that in the future when we access, so it's not quite inconceivable that we will query the user based on the user ID, right? And also one more thing I've forgot here is that we want the email to be unique, so we don't allow a person to use the same email. Okay, so that's one table. Let's just check to see if we make any mistake on this. Okay, so schema. Okay, I'm not in that directory, so let me go into the directory first. So when I will say source schema, it's a destructive command. Oh, I have a error. Where's the error? Let's have a look. Right near use needs that. Okay, cool. Another syntax. Key user ID. Making a lot of mistakes. Okay, so that's the index. Okay, right. So we can just say like show indexes from user, right? So we've got okay. So we've got two in. Okay, so maybe perhaps I don't need that. Let me just try this. So if I have, so I believe that if it's a key, then the this would be unique. So let me remove that. Okay. So I've got two index. So the next thing I'm going to create is the kbot, this guy. So create table kbot, and I will say the first field is the primary key is bot ID. And if you recall, the bot ID from the first season is 8 characters. I generated, in the first season, when we generate the ID in Angular, what I did was I used a UUID, and then I just grabbed the first 8 characters. I think UUID version 4 that I used, and I just grabbed the first 8 characters. So in here, we're going to match that by saying that the character is 8, and it's not now. And the second one I'm going to use is the user ID. The user ID here is a foreign key. We should use this to create a relationship between user and the bot. So this has to be the same as the type has to be the same. And then we'll say we'll have title comments, title title, title we'll say var char maybe 64, and then I'll say comments. This will be tiny text. Okay, and then I'll say created on. This will be timestamp. Not now. Oops, I spelled incorrectly. Created is the timestamp, and updated on. We won't be using this just yet. We only use it when we perform updates. Updated on. This will be timestamp as well. However, this one we will say on update. We will say current timestamp. So we will say when you update, automatically update this field with the timestamp that is been updated. Okay. Now we'll do the same thing. We'll say the primary key is the port ID, and we will now define a relationship, what we call a foreign key, between this table and this table by specifying that the user ID is linked to this. So we'll say constraint, we'll define a foreign string constraint, constraint foreign key, user ID, foreign key, user ID, references, user ID. And what we want to do is this: if we delete the user, in this particular case, I also want to delete all the all the bots. So if I delete the user, I want to also delete all the bots associated with this user. You may want to keep it, but in this case, I want to delete it. I don't want to have any dangling bots. I will say on delete cascade. There are quite a few options here. You can say, but leave them alone or whatever. So I'm going to say cascade. That's my second one, and I'll create a third one. The third one is pretty much going to be the same as the second one. Structurally, it's going to be the same. We will say the card ID. This will be an integer. Move this up. This will be an integer, not now, and this will be auto increment. And this will be the primary key for the for this bot, and we are using auto increment because we don't really care about the ID, about the primary key of the card. And then the next thing we want to do is this. Oh, sorry. Okay. So one more. Okay. Right. And then I want to say bot ID char 8, not now, and then I'll say description. This will be, let's say varchar 64, not now. Then priority, this will be tiny int. So if you recall, our priority is enum, only 3 values, 0, 1 and 2. I'm going to put tiny int, and I will say default to 0. If you don't tell me what the priority is, I'll default it to 0. Again, I'll do the same thing, primary key, and the primary key will be card ID, and the constraint foreign key bot ID, foreign key references, bot ID. Again, the same thing on delete cascade. Okay, that's my that's the schema. So let's run this and see if I've made any error. Okay, nice. So we have created it and there are no error. Let's have a look at our table, our database. Use stack. Show tables. Those are the tables. Describe user. Okay, that's good. And then we'll do the next one. We'll describe table bot. We've got the bot ID, which is the primary key. We've got the user ID, which is the foreign key. And then we've got title with comments created on, created by. Notice that updated, that is the default value every time when we perform an update. And then finally, we want to say describe card. Right. Again, everything is the same. The only difference here is that the primary key is an auto increment. So now what we will do is this: we will give access this database to Bunny. So we'll grant all privileges on need stack everything to Barney. To maybe I don't have this. Barney at grant privileges. Yes, but okay, yeah, right. So let's exit and just check if you can log in to Barney, and then we can actually see the table. My CLI MSU Barney. Show databases. See what we can see. Notice that we can see need stack. Okay, so use need stack. Show tables. Okay, tables. Right. Now that we have grant access to Barney, let's insert some. Let's seed the database with some data, some initial data. I'll create a separate file called data, and then I'll say use need stack. Insert into user. Let's see what we're going to insert into user. Let's grab these three fields from here. User ID, email, and password values. Okay, so let me do this because I'm going to reuse this again. I'll say Barney. So I'll say user ID. The email will be barney@gmail.com. This is faking it, and a password. We want to encrypt the password, or not encrypt, but we want to hash the password. So I'll use the MySQL SHA1, and the password is just Barney. Okay. Okay. So, sorry. This user is not the database user. This user is the need stack user. So in this case, let me just use a different one, different user. Okay. So this user is. I made a mistake. I shouldn't confuse. We use Barney to log into MySQL, but this user that I'm creating, this Fred user, is the user of need stack. Okay, of the need stack application, not the database user. We insert that, and now what we would do is this: we will create we'll create a few kbot for this user called Fred. So let me create one of these things. Set bot ID. So the bot ID, remember we said that the bot ID is 8 character. So we have to have 8 character. And what we will do is this: we will pick up all these things. And put it here. Bot ID, user ID, okay. I'll say values. Okay, I don't like inconsistency. Just put it up here. Values. Right. So the bot ID is going to be just bot ID. References that one, and the user ID is just going to be user ID. References Fred, and then our title, I'll call this my first bot. No comments. Created on. I'll put the current timestamp. And now we will insert a few cards into this particular bot. Let's have a look again at what are the fields for the card. So we got 4. Okay, we don't need a card ID because that is auto-generated. The primary key is automatically generated, so it's database provide like a sequence. We don't need that. We will need a bot ID. We will need description, and then we will need priority. say the bot ID is bot ID. The description, let's say to do hash 1, priority let's say 0, and we'll add a field. We'll do a batch insert. We'll say this is 2 and this is 3. So this particular bot has 3 cards, and let's change the priority a little bit. 1 1 like that, and let's insert another bot. And we'll change this one to EFGH. And okay, so since this is like hex, I cannot go more than I cannot have any alphabet, you know, like F bigger than F, right? So let's repeat again. Let's say A B C D, and then I'll just go 5 6 7 8, and let's call this, you know, my second bot, and I'll leave it as let's make it as 2 cards for us. Okay, so let's insert. Let's try inserting this in. Right, so let's have a look. Select all from not user. Okay, this is the SHA1 password. Okay, the password is funny, so let me just change this to Fred. Call this Fred. Let me recreate the whole thing again. Let me source the schema again. So we have clean database, and then now we will insert the data. Select all from user. So this is Fred, the password, and then we can say select all from keyboard. There's 2 cards in there, and then select all from kcard. Okay, so the database is done. Now what we will do is this. So the first part of this episode is done. For the second part, what we will do is we will create a connection pool in our database to in our application to connect to this database. So let's exit and go back to our application. Let me open this guy up. Right. So before I begin, let's clean this out a little bit. I want to delete all this. I'm going to only keep the this is what we did yesterday. This is the Bootstrap application. When it starts up, the application creates an instance of the Nest application, right? We disabled the X powered by. We also added the logging. This is all from last week's episode, and we also provided like a command line option for the user to type in, to specify, to say what port they want to use. So for this episode, what we will do is this. We will add a connection pool, a database connection pool. And before I do that, what I will do is this. I will clean this up a little bit first. I want to delete this and the service, and we will generate our own service. So I'll delete this, yes. I'll delete this, yes, and I'll delete also the service. And then I'll have to come to the module to clean it up. Oops. Okay. Now I need to do a few things. Let's go back to backend. I need to install the MySQL driver. If you're using Node, one of the most popular or most commonly used driver is this MySQL. However, I'm going to use MySQL 2. MySQL 2 built on top of MySQL. It is API compatible. And the nice thing about MySQL 2 is that instead of using callbacks to get the result, it's got built-in promise. So I'm going to use MySQL 2. MySQL 2 also has TypeScript support. So npm I'm going to create MySQL 2. the next thing I'll do is I will install the types. Okay. SQL types. And one other thing, while that is installing, I'm also going to install something called nest.js configuration. Okay. Nest.js provides like a very simple service that allows you to access a configuration throughout your application. Application configuration throughout your application. If you recall, we use .env. .env is good. It's really nice. It's really nice in TypeScript. However, this is better because because it provides first of all, the configuration module is built on top of .env, so you can use back the same .env file. Secondly, it has got nice things like you can specify where your development environment variable is, where your environment files is, and also you can have things like defaults and what have you, and automatic type conversion. Okay, so we're going to install this. So the way to do that is to install this using the nest.js config. So let me clear this. npmi now we are ready to start our application. What I'll do is I will create a file called so the first thing I need to do is this. I'm going to need to import in the config module. The config module has to be imported. The default is that it's going to look for this file. This is our configuration file. Okay, right? And what I'll do is I'll create a service to initialize our connection pool, our database connection pool. What I'll do here is I'll create a file called persistence, a service called persistence. Oops, I haven't written this. Okay, so it's here. That's the file, and I will import in injectable. The Nest.js service concept is exactly the same as Angular. The service class is rather the service object, the service component is a singleton, and it can be accessed anywhere within the Nest application, right? And also with like Angular, it needs to be defined. It needs to be declared in the module under the provider. Okay, let me import in the so when we initialize the service, so the way we use that is we create a constructor, and then we will inject in the config service. Notice that I didn't make this into a member by putting a private in front here, because the config service, I'm going to use a config service in a constructor only. In your case, if you need to access the config service outside of the constructor, then you should include make this into a member. For my case, I'm just going to do this, right? To connect to the database, I'm going to need a few pieces of information. So let me just go to the configuration file first and do this. I'm going to first of all need to tell it where is the server, where's the DB host. Again, these are my name. You can give any name you want. The name, okay. So I'm going to call it DB host, and and I'm going to say here localhost. You can also provide the port in case if your MySQL port is different. I'm just going to put this here as a placeholder. You can come and change it if you want. There's a lot of people that I know, a lot of installation that I know that actually changes the MySQL configuration port, to allow to reduce the number of attacks on their database. And then the database name. In our case, it's need stack, and then the user. This is the database user, not Fred. So in this case, our case, this is Barney, and then the password, and this is also Barney. Okay, let's see how we use this. So I've injected this in. Now I need to create a configuration object to initialize my connection pool. So I will okay, let me just get code do this. Options pool options, so this guy here from my SQL2. Okay, and then I will say these options. Okay, so it's got quite a few options. Notice that there's a host. So for this one, I'll go config service get. I'm going to return a string, and then I'll say db host. You can provide a default if this is not set. I'll say localhost here. So that's one. The next one is the port. The type is number, and then this will be db port. The default is, if it's not found, is 3306. Then the next one is the database. This is a string, and then what was it? Our database name. And in here, this is need stack. The next one is the user, and then this will be user, and finally the password. There are other configurations. There's one or two more configurations that I need to set. The first is that generally I like to set this the time zone. If you don't use a time zone, then sometimes MySQL will save it. I think in a different time zone than what you are running here, right? So it's good to be explicit. So what I'll do here is this. I'll say db time zone. In my case, my time zone here is 0800. Save this, okay. 0800. So it's time zone, and what I'll do is this. Sorry, let me just do this a bit better. Okay, time zone, and I'll say plus 08. So 00. The other one that is quite critical, I think, is connection limit. This is the number of database connection in the pool. What happens is when you create a pool, in this particular case, the MySQL tool will create an X number of connections in this pool, say like 5 or 8 or what have you. Every time when a request comes in, one connection is checked out from the pool. When you finish, the connection is released back into the pool. In this way, you get to control the number of connections to your database. So again, I'll do this. So this is the number, and I'll just say connection limit. Let's say the default is I just want to go to. Oops. Here, like that. And maybe I'm going to set it as 4 here. Okay, so this is the option. Okay, So looks okay. Oh, I don't have config service. I should import in a config service. So that's why it's complaining. From nest.js config config service. Okay. So next thing is we have to decide when to create this connection pool. In Nest.js, again, like Angular, it has got lifecycle hooks. So lifecycle hooks. You can listen to when it's starting up, when the module is created, when the application bootstraps, when it's destroyed, before the application shut down. For us, what we want to do is this: we want to listen to the application startup, the application bootstrap, and the application shutdown. When the application start up, what we will do is we will create our pool. When the application shuts down, what we'll do is that we will terminate, we'll close the connection of pool. It's always good to release all the connection, so that so that we free our resources. We have to implement two interfaces: application bootstrap and application shutdown in the service here. So we'll say implements on application bootstrap. That's one, and on application shutdown. That's another one. Now we just need to write the two interfaces on application bootstrap. Application bootstrap. Right, and we will return a promise. What this will do is this: if the promise resolve, the application will go ahead and start up. If the promise is rejected, the application will not start up. So this gives us the opportunity, if we misconfigure our database by either giving the wrong host or an incorrect password, the application will not start up. Because if you remember, there's no point in starting up the application because our application is dependent on the database. We'll make this async. Okay, and what we're going to do? In here, we are going to first of all create the pool, the connection pool, and then the second thing we'll do is this: we will ping the pool. Okay, this will really test if we can connect to the pool. Pinging the pool, is not really fail-safe. It just means that whether the database is up, we can connect to the database, right? Okay, using the given username, password, and the host and the port number. So we will start off by creating the pool first. I will create a option here, a variable here called pool, and then this is the pool. Okay, I'm going to use the promise. There are actually two versions. One is the you want the promise version, and then I will also say we also need to go like you do like this pool, create pool. Again, there are many different versions. If you are using the promise, check that you are getting the promise version. Import from promise. Okay, create pool, and we want to pass in our configuration, which is right up there. Okay, right. So that's the first part. Now what we do is that we will check out a connection, and then we use that connection to ping. So this is what we do. You just say const connection equals to this pool, right? Get connection. Notice it returns a promise. So we need to go await here, like that. Okay. So now what I'll do is this. I will put in a big try here, and let me move this up a little bit. I'll say catch if there's any error. Okay, let's say finally. I'll just put all this here first. So this is what we do. We just put a little message that says pinging database. Okay. Here, pinging database, and then we'll do this. We'll go await connection ping. Okay. If this fails, it will throw an exception, which we'll catch it here. We will say console. We'll log out error, and then we'll say error fail to ping database, and then we just list out the error. And very important, we want to tell Nest that do not start the application. So here we will reject the promise by going promise reject, and we put it give the reason, give the error. Okay. Finally here, okay, before we exit, we need to release the connection back to the pool. Okay, if you don't release, then eventually the database the pool will run out of connection. In our case, we say there are 4 connections in the pool. So if 4 requests comes in, and if we don't release the connection, then the 5th request will eventually be blocked until a connection is free. Okay, so this is what we have. We need to register this with our module, which I'll do here. Okay, let's have a look. Okay, we'll start by running the application. Nest start. Let me just see first. Okay, Nest start. Okay, I see some error on application shutdown. Okay, I know why. Here. Okay, I didn't because I've implemented the application bootstrap, but I did not implement shutdown. So let me just put a little let me just put just write the method first. Oops. Basing on application shutdown, and then it takes something called a signal. You let us know what signal is received. This is a Unix signal, okay, like system, secret, whatever. It's basically a string, but I'll just put any, and it returns a promise. You just say void. That should fix it. Right. So we are pinging the database, and notice that the application can start. Let's make an error. So once we successfully ping the database, we will start the application. Let's change this so that so that we are not able to log in by misspelling the password. And we'll start that again. Notice that now we have an error. Let's have a look. Notice that we are not access denied to the database because the password is incorrect. So this is what we want, right? So it's performing a compilation. Sometimes it gets hung, so you just stop and start again. Right. So the application is up again. So before we leave, what we want to do is this: when the application is restarted or when the application shuts down because it receives a signal, we want to close the database. We want to clean up. We want to close all the connections in the pool. Okay. So now let's come to here, and then we'll just say this pool, and we'll just say end. Okay, it returns a promise. We'll just say await. We will log out to console. Okay, we'll say application shutting down. We'll just say receive the signal. Signal application shutting down. Okay, you cannot just write the application shutdown like this. What you need to do is this: you need to enable what is not called the shutdown hook, and the shutdown hook is enabled in main here. So somewhere here, you just say anywhere before the start of the application, we just say enable shutdown hook. Okay, you can you can give a list of signal. Anyway, for me, what are the signals it should shut down when it receives? For me, for this case, I'm just going to get it to shut down, with whatever signals that it receives. So notice that it's now saying that it receives signal, the application is shutting down. So let me just show you. Let's do everything again. We'll start the whole thing again. We'll just go nest. And then we'll say watch. Start watch. The application has successfully started, and now we are going to shut it. Now we are going to simulate a shutdown by sending a signal, right? So we'll just do a right here. Notice that it's received a signal and shutting down. Generally, if you are for example, deploying this inside a container or in Kubernetes, when the pod gets rescheduled or the pods gets moved from one node to another node, this is what it will do. It will send the Kubernetes will send a signal into the pod. Generally, it will be like signal, and then this gives a chance for your application to shut down. So we will have come to the end of this episode. From the next episode onwards, we will start looking at how we can implement resources in our application. Today in this episode we have built our data model, and we have built a connection pool to access our database. So the next episode we will look at create some resources, create some controllers in Nest to retrieve some of our data. Till the next episode, till then, stay safe. Oh, by the way, this branch is part 19. Okay, right? So this is the second episode of the second season. Okay, right? See you in the next episode.